All right, this is 8.3 geometric sequences. So just like arithmetic sequences, we have geometric sequences, and a geometric sequence is a sequence that has a constant common ratio. So whereas our arithmetics had a constant common difference, it has a common ratio between any two consecutive terms. So we'll use R to represent that that ratio, and it's any term divided by the term previous to it. So any term here divided by the term previous. Let's look at number 2 right here to get an idea. So if we take any term, we'll take 25 divided by the term previous to it, it's 5. If we take 125 divided by the term previous to it, it is 5. 625 divided by 125, it is 5. So we can say that our common ratio is 5. Coming over here, we'll go ahead and make a quick table to see if we can find out what our common ratio is. And this is going to be n, and this is going to be a sub n, or 2n. Oh, I like that. Okay. A sub n. So one, first term, second term, third term, fourth term. We'll only go that far. So 2 to the first power is 2. 2 squared is 4. 2 cubed is 8. And 2 to the fourth is 16. So we have 2, 4, 8, 16. Divide 4 by 2 is 2. 8 divided by 4 is 2. 16 divided by 8 is 2. So we can see that our common ratio is R equals 2. You'll notice that that 2 is the same as the base of that exponential equation. We'll talk about that in a minute. Determine if the sequence is geometric. If it is, state if it's what's the common ratio. Well, if I come in here and go 5 divided by 1, that should equal 9 divided by 5, but it doesn't. They don't equal each other. And 9 divided by 5, the term previous, does not equal 13 divided by 9. So not geometric. In fact, in this case, 5 minus 1 is 4, 9 minus 5 is 4, 13 minus 9 is 4. So this sequence here is actually arithmetic with a common difference of 4, but it is not geometric. Come over here to number 4, and that's the problem we just looked at up here. So we know that yes, indeed, yes, geometric, and the common ratio is 2. Lastly, we come over here, and our initial thought might be to say that, yeah, it is geometric because we have that same, 3 to the n. But just very quickly, I'm going to do n, a sub n. First term, second term, third term. We just have to look at 3. 3, the first power, is 3. 3 plus 2 is 5. 3 squared is 9. 9 plus 2 is 11. And then 3 cubed is 27, plus 2 is 29. Well, if I look at these ratios, if I take a term 11 and divide it by the previous term 5, does that equal 29 divided by 11? And it doesn't. Okay? And the reason is because of this plus 2. So 3 to the n would be geometric, but not since we're adding, or if anytime we're adding or subtracting a constant to it, it means it's not geometric. And this is saying, what type of function do geometric sequences mimic? So what does this mimic? What does this mimic? And the answer is it mimics a exponential function. It says, what feature of the function should we look to find the common ratio? Well, again, using that example we had, here's an exponential function, and this right here, that 2, that is the base of the exponential function. Oh, it's terrible. I'm trying to hurry too much. It's the base of the exponential function. Okay, let's see. We just gotta keep moving forward here. So look at the geometric sequence. Let's just go ahead and find what our ratio is. 4 divided by 1 is 4. 16 divided by 4 is 4. I think it's safe to say that our ratio is 4. So we want to find the nth term. This is the same thing we did in arithmetic sequences. If we have a sequence and we want to find any term, we want to find the 10th term, the 25th term, the 100th term, or whatever, we need to have a formula so we can easily find that. And we did that with arithmetic. We can do that. Same thing with geometric sequences. Like if I wanted to, come here and I wanted to find, this is 1, 2, 3, 4, 5. We have the first 5 terms, but if I wanted to find like the 15th term, okay, or if I wanted to find, the 100th term, how can I do that? And the formula is a sub n, the term we're looking to find, equals the first term times r to the n minus 1. So if we know the first term and we know what our common ratio is, then we would use this formula. So for example, if I wanted to find the 100th term of this ratio up here, the first term is 1 times our r, which is, we said was 4, to the 100th minus 1. So 1 times 4 to the 99th power. And I don't have my calculator with me, so I have no idea what that is. But you have that idea. Then if we're given 2 terms, let's say we're not given r. We're just given 2 terms. Well, if we are given that, then it would be a sub n equals a sub m times r to the n minus m, which is the same as this equation here, only in this case it was the first term, so that's why we use a 1 here. But if we have any term, if we have the second term or the third term or whatever, then we can just use this equation. Now the caution over here is that if n minus m, and I'm talking about right here, if that is even, then you get a positive n negative r. So there's 2 rules or 2 solutions. All right, let me stop for a quick minute, and then we will work through these problems. No, we'll just keep going. All right, let's see. Find the formula for the nth term. 6 divided by 2 is 3. 18 divided by 6 is 3. So we're going to say r equals 3. So a sub n equals 2, our first term, times r, which I have, r, which is 3, to the n minus 1. So we could find any term in this sequence by using that formula there. Come over here, same idea, a sub n equals the first term, 5, times r, negative 2, to the n minus 1. And we can find any term in that sequence. So in this case, we have 2 terms. We don't have the r. But first we're going to use our formula, a to the n equals a to the m times r n minus m. The term that is, let's say, the furthest away, the larger term, so the 6th term, it's always going to be your a sub n. And then your lower term is going to be your a sub m. So we would write this, we go 27 equals 1/3 r, and then this n here, is that 2? Oh, I'm sorry, no, n is the 6, sorry. N is the 6, and m is the 2. So we have 27 equals 1/3 r to the 4th. Multiply both sides by 3, That is a 3. These cancel out, and this gives us 81 equals r to the 4th. Come in here and take the 4th root of both of them, and now we have r equals 3. Now, let's go back here. When we did 6 minus 2, we got 4. 4 is even, so we actually have r equals plus or minus 3. So you could say, I guess one possibility for an answer would be, say, a sub n equals 1/3 of positive negative 3. But then you have to say n minus 2. And n minus 2, because this is the second term here. We'd rather have it where we r equals plus or minus 3. Let me erase this. We'd rather have it where we have our first term. And our first term, a sub 1 equals 1/9. Why is it 1/9? Well, because I take 1/3 and I divide it by my my r, which is actually positive negative 3. So that's going to give me, that's 1/3 times 1/3 equals positive negative 1/9. So now I can write my a sub n equals 1/9 positive r, 3, n to the 1, or a sub n equals my negative 1/9 times negative 3, n to the 1. And anytime you're doing these, you can always go in and you could plug this in to here, to both of those, and if they work, then you know you have the right answer. Okay, last one is just here. This basically says, okay, we have the first term is 15, and this is just saying that every term is going to be 4 times any term is equal to the term after it. So 4 times a to the k is going to equal a to the k plus 1. Or, in other words, I'm not saying this very well. That's our r. R equals 4. So a sub n equals 15 times 4 n minus 1. All right, now